Welcome back, everybody. Let's take a few more questions on partial fractions. The first one is x cubed plus 6 over x squared times x plus 3. We want to resolve this into partial fractions. So we need to check first of all to know if it's a proper or an improper fraction. If we expand the denominator, we're going to get x cubed plus 3x squared. That means the degree of the denominator is 3 and that of the numerator is also 3, which means it is an improper fraction. We know that if it's an improper fraction, the degree of the numerator will either be equal to that of the denominator or greater than that of the denominator. So now we need to divide the numerator by the denominator. Let's do that. Since we have found that it's an improper fraction, that's what we do to make it a proper fraction. X cubed plus 6. Let me just put 0x squared so we don't get confused. Plus 0x plus 6 divided by x squared times x plus 3 is the same as x cubed plus 3x squared. Now, x cubed divided by x cubed is 1. So we multiply the whole of this by 1. And that's going to give us x cubed plus 3x squared. Now we subtract. X cubed minus x cubed is 0. 0 minus 3x squared is minus 3x squared. 0x minus nothing is nothing. 6 minus nothing is 6. That means the quotient is 1 and the remainder is minus 3x squared plus 6. So it simply means x cubed plus 6 all over x squared times x plus 3 is equal to, you write the quotient and you write the quotient and say just say quotient plus remainder over divisor. That's what I'm going to do. So that means 1 plus the remainder is minus 3x squared plus 6 all over the divisor, which is x cubed plus 3x squared. Now I can write the fraction minus 3x squared plus 6 is the same as 6 minus 3x squared. So that's equal to 1 plus 6 minus 3x squared all over x cubed plus 3x squared is the same as x squared times x plus 3. Now, by reducing the improper fraction to a proper fraction, by dividing the numerator and denominator, the numerator of the improper fraction by its denominator, we have got a proper fraction, which is this. We can see that the degree of this denominator is 3 when you expand, and that of the numerator is 2. So that means this is a proper fraction. So we resolve these into partial fractions and then add it to 1 to get the final answer. So let's go. 6 minus 3x squared all over x squared times x plus 3 is equal to, now x is a linear factor, but its power is greater than 1. That means it's a repeated linear factor. So whatever the power is the number of partial fractions that it is going to have. The power is 2, so it will have 2 partial fractions. So the first power, which is x raised to power 1, the numerator of the partial fraction of the first power, which is x raised to power 1, is just a constant. So that's a over x raised to power 1 plus the numerator of the second power, which is x raised to power 2, is also a constant because the factor is a linear factor. So plus b over x squared plus x plus 3 is also a linear factor. So we just assign a constant to the numerator of its partial fraction. So x raised to power 1 is same as x, so I can just leave that as x. Now I can simplify further. The LCM of the denominators is x squared times x plus 3. When I divide this by x, I'm going to get x times x plus 3, and I multiply that by a to get ax times x plus 3, and I do the same for the remaining two fractions to get b times x plus 3 plus cx squared. Plus cx squared. Now the numerator of the left hand side, the denominator of the left hand side is the same as the denominator of the right hand side. That simply means the numerator of the left hand side is also going to be the same as the numerator of the right hand side. So I can write 6 minus 3x squared equals ax times x plus 3 plus b times x plus 3 plus cx squared. Let me call that equation 1. Now I want to put x equals 0 in equation 1. If I put x equals 0 in equation 1, a times 0 is 0, and that means the L of this is 0. 0 squared is 0, which means the L of this is 0. So I'm going to be left with 6 minus 3 times 0 squared equals b times 0 plus 3, and that simply means 6 equals 3b. When we divide both sides by 3, we get b equals 2. Now what can we put in equation 1 to get another constant? I want to put x equals minus 3 in equation 1. If I put x equals minus 3 in equation 1, minus 3 plus 3 is 0, that means the L of this will be 0. Minus 3 plus 3 is 0, that means the L of this will also be 0. So I will only be left with the constant c. So let's put x equals minus 3 on the left hand side of equation 1. That means 6 minus 3 times minus 3 squared equals c times minus 3 squared, and that simply means minus 3 squared is 9 times minus 3, that's minus 27. 6 minus 27 is minus 21 equals minus 3 squared is 9 times c, that's 9c, and that means c equals, when we divide both sides by 9, c will be minus 21 over 9, which is minus 7 over 3. Maybe I should write that, minus 21 over 9, and that means c equals minus 7 over 3. That's c. Now we are left with b. What can I put in 1 to get b? I can just put any small value in 1, substitute any small value in 1 for x to simplify equation 1, and then I'll be able to solve for a. Okay, we only want to find a. We've got b and c. So let me put x equals 1 in equation 1. I'll paste it somewhere there so we can see the equation we are substituting. You are putting x equals 1 into. Yes, so I want to put x equals 1 in equation 1. Putting x equals 1 in equation 1, 6 minus 3 times 1 squared will be equal to a times 1 times 1 plus 3 plus b times 1 plus 3 plus c times, I want it to contain it, I don't want to write it on two lines, 6 minus 3 times 1 squared, putting x equals 1, will be equal to a times 1 times 1 plus 3 plus b times 1 plus 3 plus c times 1 squared. Now I can erase this, and that simply means 3 equals, of course, 1 squared is 1 times minus 3, that's minus 3, 6 minus 3 is 3. 3 equals 4a plus 1 plus 3 is 4. A times 1 is a, a times 4, 4a, plus 4b plus c. That simply means, what do? I already have, that simply means 3 equals 4a plus 4b. b is 2, that's 4 times 2 plus c, which is minus 7 over 3. That's simply plus times minus is minus, that's the same as minus 7 all over 3. Now I'm bringing all of the, okay, let me do this first. That means 4a plus 8 minus 7 over 3. So I'm bringing all the constants on the right hand side to the left hand side, and that means 3 minus 8 plus 7 over 3 equals 4a. Yeah, that's what it means. Now what do we get when we simplify the left hand side? 3 minus 8 is 3 minus 8 is minus 5. So what's minus 5 plus 7 over 3? That's simply minus 8 over 3. So that means minus 8 over 3 equals 4a. And when you divide both sides by 4, a will be equal to minus 8 over 3 divided by 4 means times 1 over 4. And that means a equals minus 2 over 3. So now I know all the constants. A is equal to minus 2 over 3, b is equal to 2, and c equals minus 7 over 3. So that means the fraction that I resolved into partial fractions, which is 6 minus 3x squared over x squared times x plus 3, is equal to a over x. That simply means minus 2 over 3x plus b over x squared, that's plus 2 over x squared, plus c over x plus 3, plus c, that means plus times minus 7 over 3, that will be minus 7 over 3 times x plus 3, minus 7 all over 3 times x plus 3. And that's it, very, very simply. Let me go back to that fraction. Let's go back to that fraction here. This is a fraction. This is it. 6 minus 3x squared over x squared times x plus 3 equals a over x plus b over x squared plus c over x plus 3. So we've got that now. So that simply means, so what do we now do? That simply means this, or the original improper fraction that was given, x cubed plus 6 over x squared times x plus 3 is equal to 1 plus the whole of this. So that simply means x cubed plus 6, which is the original fraction, x cubed plus 6 over x squared times x plus 3 equals 1 plus the whole of this, which we have split into this. So I'm just going to write 1 plus minus 2 over 3x, that's the same as 1 minus 2 over 3x plus 2 over x squared minus 7 over 3 times x plus 3. And that's it, very, very, very simply. I don't know if I can move that, yeah, to the left a little. All over minus 7 over x 3 times x plus 3. And that's it, very, very simply. Can we take a second question? Okay, let's take another one, another very simple one. What should that be? X plus 1 over x squared plus 1 over x plus 1 all squared. Let's take this. Resolve x plus x squared plus 1 all over x plus 1, the square of x plus 1 actually. If we expand the square of x plus 1, we are going to get x squared plus 2x plus 1. That means the degree of the denominator is 2 and that of the numerator is also 2. Since they are equal, it means the fraction is an improper fraction. So before we resolve into partial fractions, we have to divide the numerator by the denominator. X squared plus 1. Let me fill this with 0x. Let me just write x squared plus 0x plus 1. And I'm dividing it by the square of x plus 1. And that's the same as x squared plus 2x plus 1. Now x squared divided by x squared is 1. So I multiply the whole of this by 1, which means x squared plus 2x plus 1. Now I subtract. X squared minus x squared is 0. 0 minus 2x is the same as minus 2x. And 1 minus 1. 1 minus 1 is 0. So the remainder is simply minus 2x. So that means x squared plus 1 all over the square of x plus 1 is the same as, you write the quotient plus remainder all over divisor. That's all. So I'm just going to write 1 plus minus 2x over, the divisor is x squared plus 2x plus 1, and I can write that as 1 minus 2x over x squared plus 2x plus 1 is the same as the square of x plus 1. Now this is what we are going to resolve into partial fractions. So 2x over x plus 1 all squared is equal to, x plus 1 is a linear factor, but it has a power that's greater than 1. That power is 2, so it will have two partial fractions. The first one will be a over x plus 1, and the second will be b over the square of x plus 1. LCM is the square of x plus 1. So we're going to have a times x plus 1 plus b. Now that simply means 2x is equal to, the numerator on the left hand side will be equal to the numerator on the right hand side plus b. Now if we put x equals minus 1, that means 2 times minus 1, this will be 0 because minus 1 plus 1 is 0. So the whole of this will be 0. That means 2 times minus 1 equals b, which simply means b equals minus 2. Now if we put x equals 0, 2 times 0 will be equal to a times 0 plus 1 plus b, and that simply means 0 equals a plus b, and I already know b is minus 2. That means 0 equals a minus 2. If I bring minus 2 to the right hand side, it becomes plus 2. So that means a equals 2. Now that simply means the fraction that we have just resolved into partial fractions, which is the whole of this, 2x over the square of x plus 1, 2x over the square of x plus 1 is equal to a over x plus 1, which is 2 over x plus 1, plus b over x plus 1 plus b over the square of x plus 1. That's plus times minus is minus, so that will be minus 2 all over the square of x plus 1. So that therefore means the original improper fraction that we intended to resolve into partial fractions, which is this, yes, it's going to be 1 plus what we got for this. But don't let's make that mistake, there's a minus here. So we have got this, we have resolved this into partial fractions, so we have to multiply that by minus 1. I'm going to write it this way. x squared plus 1 over the square of x plus 1 is equal to 1 minus 2x over the square of x plus 1. And we know that we know that this is the same as the whole of this. So that's what I'm going to replace. So that's what I'm going to replace this with. And that means that's equal to 1 minus, I want to write it this way, 2 over x plus 1 minus 2 over the square of x plus 1, which simply means 1 minus 2 over x plus 1 plus 2 over the square of x plus 1. So that simply means x squared plus 1 over the square of x plus 1 is equal to the whole of the right hand side. And that's it, very, very simply. It can be that simple if you know the rules and you are careful enough to solve for or to find the values of a constant. Alright, thank you very much. I'll see you in the next. Bye bye.